Welcome everybody. My name is Paweł. I'm a software developer at Visuality. And today I'm going to talk about event sourcing and how to do it in Ruby. Well, if you know anything about event sourcing, that's great. Maybe you'll know some more, or maybe I will learn from you. If you know nothing, hopefully you will learn something. And I will be putting a stronger stress on one of the available tools. So if you know anything about it, please come to me and let's chat. This presentation has a very simple plan. We'll start with an easy part. I will tell you what event sourcing is, based on a short story. Then a bit harder part, the part where I will explain some concepts. And it will be a bit harder because you'll have to understand. And then fun part, we'll do the one thing that you should never do. So we will perform a live demo. Okay, let's start. Meet Mary. Mary is a client of our e-commerce. She has been with us for years. Still, she's made only one purchase. We also know her interests. She's interested in chess and crime novels. Let's see how we know that. We have a very standard e-commerce system with a relational database, as we all know and love. We have users, of course. So we know that she's been a client of our e-commerce for years. How do we know that? We have a record in users table with a created ad with some first name, Mary Jane, last name Parker, email. Doesn't really match her name, but still. Let's go forward. She's made only one purchase. We have that in our, of course, orders table and some line items. So we know when she's made that purchase, the stats, the number. We know what she has bought and all that. Standard as it gets. We also know her interests. We have, of course, some relational data. Her interests matched with her, with some level. We know about those are crime novels, those are chess, as standard as it gets. Let's sum it up. So we have some data stored in a relational database. That information is persistent. That's our source of truth. We all know how it looks like. There were some events in the past that led to this state. For example, she has pressed a button. She has added shipping information. She has added something to cart. She has changed quantity in cart. But those events were transient. We didn't really care what they were. What we cared about was the final state of that information. At this point, we know who, Mary, what state is right now. Let's try a different approach. Let's meet Mary once again, but now through events. So we'll go over every change that was introduced to our system by Mary. Let's start over. It's a bit different view. We don't have a relational database anymore. We have events. Events as created, first name set, last name set. So similarly to the standard system, we know she has created her account with first name, last name, and some email, which, well, it now matches the name. Then she has changed her first name. Then she has changed her last name. What else do we know? She's made that order that we remember. It has been created. Some number was generated for it. She has added a line item, another line item. She has changed the quantity, apparently. But what else? She has added one more item. She has been thinking for a day about it, then she has removed it and completed the order. It's the same order that we looked at before, but now we have a bit more information. And about her interests, of course, as you can imagine, her interests over the years has also changed. So we have some entries, and then we have some more. Analyzing those, we can conclude that she's not only into crime novels and chess, but she used to have different interests. Again, let's sum it up. She's a client of our e-commerce, but over the years, she has adjusted her first name entry and she has changed her last name. It's likely that she's been married or divorced. She has made one purchase, but was also thinking about buying a survival kit. She's interested in chess and crime novels, but she was also into hiking and sailing at some point. Now, data is stored as event objects, and those events are our source of truth. Those are persistent. We can always take all those events and project them to figure out what's the current state. If we add all the events from the history, we can conclude what's the current state. So we can come up with something similar that we used to have in a relational database. But now we can analyze the entire history of what has happened over the years. We know who, what, and why. Why? Why? Because we can figure out what events led to other events. So we know the whole story. And that's called event sourcing. It's a pattern for storing data as events. So every change of state of our application is saved as event object. Those events are stored in the sequence. That's like one of the most important things. So when event happens, it's appended to a log. It's never changed. It's never removed. It's never adjusted. It's always appended. It's like real world. You cannot change the past. You can only add additional events. Let's go over a use case. And it's not new, it's not unique, and all props to Greg Young, who is the person you want to go to if you want to know more. Go there, the link will be available later on as well, at the final screen. But if you want to know more, go to him. So let's go over like a most classical use case, similar to what we already had. We have two shopping carts. The one on the left has shoes in it, jacket, customer information added, and the order was finalized. The one on the right is almost the same, but someone has also added a tent. But shortly prior to finishing the order, the tent was removed. We can ask ourselves, are those the same? Yes, they are. The final outcome is completely the same. We've sold just as much stuff on the left and on the right. What we miss, having only the information on the left, is pretty much it, information. We've lost information. We don't know that someone has added a tent and removed it. And if you think that's worthless, let's ask that to the marketing team. Can they do something about it? Why this tent was removed? Maybe the guy who bought it or didn't buy it, maybe his wife was looking over his shoulder, Or maybe his paycheck was late. Maybe we should advertise it to him in 2 days. Maybe he'll buy it. But we have to know about it. So let's imagine your boss is here or sees it and goes to you and figures out that, hey, that kind of report, what was removed from our cart 5 minutes prior to finishing the order, maybe that has some information, let's create it. But forget about this event sourcing thing. Let's do it in our system. So, of course you can do it. You go in, you create models, you create data flow, you store that information, you create all the services, or whatever we do in Rails. You push it to production, and what do you have? Completely nothing. You don't have that data, unless you went through all the logs that you probably didn't have. You start collecting the data. You collect, and after a month you come up with a great report, and your boss says, meh, I want it differently. So you go on, and you change, and you again have nothing. And you can only see the data that you started to store once you were told to do so. However, if you started with event sourcing, you would have all the events from the entire past. Up until this point, prior to the moment that your boss came, you didn't know that you have to store some information or figure out some information, some report about things removed from the cart. But at any point, you can go back to your events because they are persistent, and you can come up with this report or any other report for the current state or for any state, any point in time in the past. So the gist of it is don't lose data. If your application has a point which can be reached in 2 different ways, and you don't know what was the path the user took, you've just lost data. Is it worth something? Nobody knows. But it might be. In a year or 2 or 5, it might be worth something, and you cannot even estimate how much. Events allow you to stop losing data. And that's the end of part 1. Do you have any questions so far? Maybe in Polish.
So what about the amount of data? Because if you event source, instead of a single record in the database, you can get 10 or 20. So your database grows way faster than with a database that stores only the current state. How do you suggest this should be handled?
Of course, that you have to start thinking how much it costs. How much it costs to put stuff somewhere in the cloud, let's say. And of course, if you want to have constant access to the data, you have to store it in a database. But you don't have to. If something is 5 years old, you probably don't need it. You might just log it. And that's storing data on S3 or any other provider. It doesn't get cheaper than that, really. So storing data nowadays is, I know it is a cost, of course, but you have to value it somehow. The amount of events grow. You never remove them. They are always there. But of course, it goes with a use case. If you do something very simple, then you won't have much events. If you do something complex, you will get more events. But if you do something complex, you probably actually need that story. And on top of that, I guess every one of us with a decent history has created an audited log and put entire entities, entire history of everything that has happened in the system, and we store that either way. This is pretty much the same. You have audited log out of the box, and you store it just as if you would store audited log. Because, yeah. But apparently, there is nothing cheaper, I guess, in the cloud than storing data.
Files, yes, but if it's a database, then you need it in RAM, and then it gets more expensive, right?
Of course. But if you want to have a business that relies on that data online, then if it's needed for your business, then you probably, it's not, okay, let me start over. It's not more costly than storing that data in a relational database because it's the same data. Eventually. I don't know how to put it. If you have a business that relies on, that needs that kind of information, or would be more reliable or whatever, having that information, you probably might be willing to take that cost. I cannot give you any figures. You can probably do it better than I can. But how do you think that how much would it cost to store, let's say, 10 terabytes of data?
Maybe we'll talk after your presentation, right? And I don't want to interrupt.
Sure, but it's a valid question. It's always about the amount. There are two questions about the amount of data, the volume of data, and how do you work with events when you have 500 million of them. But that will be after the second part. Okay. Any other?
So maybe this is just the specific case because you mentioned that there is a data that we want to know that some product was added and then it was removed. And there comes a question about the cost of development of that because you need to change the way how you store data, how you work with data. You need to educate your team probably and maybe whole company. And why just don't use something like Google Analytics, which stores data like this and they have tools for analyzing and everything. Because you can just store those events. You can go with traditional way of development or maybe even use some framework or ready shop application and then just rely on the Google Analytics or other tool like this. Is it any better? Because there is a development cost of the events.
You have two ways. One, when you go with Google Analytics, you have to say what to analyze, what to save, right? So you have to put that in that JavaScript or whatever, wherever you put statement like log me that someone has done something. And you can do it with this as well. Well, more or less. You can use the system that we'll be talking about and save those events. So you can do it, for example, in that way. That would be more like an audited log, which you can analyze, and you can rely on your own tools. But again, it's not the point of the question. This is not something new. This event sourcing stuff has been with us for years. We in Ruby just tend to not use it, because we use Rails, and Rails is everything to us. So, if you compare creating online store using this with launching a spree instance, that's like world apart, of course. But if you plan to create online gambling, and you would like it to be secure, and you'd like it to be, well, checkable, for the lack of better word, and you would like to check everything that has happened in the history, you wouldn't create a CRUD operation for creating a bet, because that, or changing the amount, you would have to save everything that would happen, and this is for you then. For online, so going back, this is hard. Doing this is hard. And doing it in a way that I'll describe is even harder. There are people, there is, of course, Arkansas, who does, well, the team does DDD with event sourcing, but they do it differently. They use their own software called Rails Event Store. And they create Rails-like application using event sourcing, but they do it differently, and they do it in a very simpler way. Because this, what I'm about to show you, is fully asynchronous. You have an event, and then something happens. How they do it is that they, I, again, don't know much about it, haven't really worked with that apart from some research, but they do everything in one transaction. So it's still database server request, controller request, and events happen, but it's all stored, it's all saved within one transaction. So you have events and you have other things. So it is doable. They've figured out how to do it their way using event sourcing. But doing it in a very classical asynchronous way is hard, and I wouldn't recommend it for a simple system. If something is a CRUD, then it is a CRUD. Let's just keep it that way. Let's go back to that after. Okay. Sure.
So, like, the theory is nice about, like, we have all the events and you can just go back, versus implementing, like, the storing of specific events that you were describing. I'm just wondering, like, in practice, do people that implemented the systems had those problems that they actually, like, forgot to add some events? Is it like when you design the system, you add everything that you are doing as an event, or like you add most of the stuff and you forget about some of those?
You plan the entire system. It's not unchangeable. You can always add something, but normally when you do it like this, let me show you the next screen because that would answer some things. So when you go into this world, first of all, you learn what CQRS is, so command query responsibility separation. You kind of go right into DDD, domain-driven design, where you actually can design the system better and you understand what's in the system. So you don't forget about a thing usually, because you have things like event storming, where you have like 5,000 pin cards on your wall, and you have everything described. And you find your bounded context, and you figure out the entire system before you move forward. I've been in a team which was implementing something based on event sourcing, based on this tool, and that was for invoices, for a portal, and we've been doing it for like a year or two. We had the time for it, but it really took time to actually figure out and to name every event, to name and to figure out how to do it properly, and it's still ongoing. All right, but having this, let me move forward because we'll answer some questions right away. So I told you that once you go into this, you kind of have to at least know what this is of CQRS for sure. The rest is kind of the next step, but well, the same thing that I tell to my morning exercises. Not today. We'll skip that. We'll just talk about event sourcing. So I will explain you some concepts behind it. All right. So we'll be using a very, very specific toolkit, Eventide project. They've created a toolkit, again, for Ruby. And to be honest, the people behind it are some of the most brilliant people in Ruby community. And even people who don't agree with them actually say so. So Scott Belwer, one of the co-creators of Eventide, you can find much of his stuff on the internet and many talks by him. that apparently can change the way you think about programming and about many things around it. But let's move forward. So they've come up with this toolkit, and core of it is MessageDB. That's event store. So it's, let me look at this. So it's MessageDB is event store, so it's the place where you store your events or in fact messages. And it's implemented in Postgres. So if you want to jump right into event sourcing, all you need is Postgres. You don't need Kafka, really. You don't need commercial event store. All you need is Postgres and this. They also came up with their own test framework, and it's really awesome. It can be used not only for this, but for any Ruby project. Also for Rails. The only thing you have to do before you start using it is forget everything that you've learned about RSpec. Like, actually everything. And it's great. Event is an effect of processing something. We also have, apart from events, we have commands. Command is an instruction sent to a component. So we have a component, let's have an order component. And we say it, hey, you, order, add line item. So add line item would be a command. Event that comes out of it is line item added. So up until now, we've been talking about those line item added events. In the event-type world, events and commands are both messages. So if we store events and commands, we actually store messages. So hence, MessageDB. All right. We don't just create messages. We actually organize them. We organize them in categories. Categories are called streams. So we have, for example, let's start from the bottom. Order 1, 2, 3. That's a name of a stream that contains events regarding order with ID 1, 2, 3. So what has happened to that order? It has been initiated, line item was added, shipping address was added, and billing address was also added. And that has happened because of some commands that were issued to that component. Again, we have a stream called order command 1, 2, 3. Naming is event type specific. Some commands were issued to that component. As you can see, initiate, add line item, and so on. So our messages, events, and commands are organized in streams. So basically, categories. Let's go back to MessageDB for a second. So as I've said, it's an event store, message store implemented in Postgres. Its implementation is just a single table. You can imagine that it's called messages. And as we've said, message can represent an event or command. Let me show you how it looks like, even though it's blinking. So it's a very simple on one hand. We have messages. Let's go over very quickly what's in it. We have a global position. Every time a message is created, it gets sequential global position. We also have a position, which is a position inside of a stream. When a stream is created, the first one is 0, the second one, and so on. Time, when it has happened, type, and the most meaningful one, data, and that's JSON-B. So you can put anything in there. The issue is how you handle it later on, but you can put any data inside of this message. Apart from that, metadata, which stores some information about what happened, why this message came to be, and other correlation stuff, and of course, ID. One thing that you have to learn once going into events, there are no numerical IDs. Everything is UUID. Why? Because such an ID has to be universally unique, because it can be created by any of the components. And we cannot ever have a collision with that. So this is MessageDB. Of course, the implementation is not just about this one table. There is a lot of database things that I may not understand fully, but it's there, and it happens when you use it. But on a very basic level, this is just one table with messages. Let's go to something fun. Why do we have those commands? What happens to them? When you do your Rails stuff, you start a server, you start Sidekick, you start processes that process data, process stuff. It's the same here. You need a process that would run and would continue to read messages. So, for example, when you issue a command, there is a process that consumes it and spits out an event out of it because of that. So, definition of a consumer. It's a process which continually reads messages from a single stream. That's important. So we have a consumer per stream we want to read from. Inside of a consumer, we have something called handlers. Again, naming is very event type specific, but it's common across the board. So inside of this consumer, we have business logic implementation, and that's in blocks called handlers. So a very simple situation. We have a line item, add line item command. That's a message put into the stream. There is a consumer which reads it, processes it, and creates event line item added. And this is where magic starts. So we had our add line item consumed by a consumer, created an event, but there is another consumer who is reading this stream and does things based on events created by another consumer. Another story, line item, add line item goes into a consumer, and this consumer issues another command to yet another consumer, which creates an event. This graph might not be completely accurate. It's just for the sake of presentation. And this, what we have in here, some message was published, some consumer has processed it, has published another message, some other consumer was subscribed to that event, to that stream, and published its own message. That thing is called PubSub. So from, as you can imagine, publisher, subscriber. And it's a messaging pattern where we don't send messages, we publish them. So me as a process, me as a component, I don't send message to anyone. I don't send it, I just publish it. And if someone wants to read those messages that I publish, it just subscribes to the message category that is put in. In this pattern, publishers and subscribers have nothing in common. They don't even know that they exist. Of course, you as the mastermind behind all that, you kind of know that what are the publishers and what are the subscribers, but they, as components, they know nothing about that. This enables us to create complex systems like this one. All right, we are almost there. Now, you can probably think, what do I do with those events? I like my relational database because I can query them and I can process something. If I want to get all the orders that have the total over 1,000, I won't go through 1 million events to figure out which one is it. And that's totally true. Events are not for that. However, the events lead to a representation of that data that you can query. That's called projection. We take our events and we project them into a readable, queryable data. We can do that in memory when we have an order and someone has added 10 line items. We can, in memory, figure out can we add next line item or not, or no. You know what? Let me skip this. It will be much more readable in this case. Let's imagine we have a stream, account stream. It's like bank account, right? You can deposit, you can withdraw. So we have an event. Someone has deposited 3 of whatever. And we can project this into our relational database. How? This event is consumed by a consumer, which puts data into relational database, because why not? Then another event comes. Someone has deposited more, and the same consumer, you can imagine it here, consumes that event and creates a representation of that account in your relational database. You can query this, right? This is Postgres. Another event comes, someone withdrawn, balance, you can see there we have amount, here we have balance. It's not the same data, it's a product of that data. Another event comes, someone wanted a bit too much from their account, nothing has changed in here. Another event about a different account, and now we have 2 entries. This is called projection. We can project into relational database, we can project into any other database. Events are the source of truth, but this table, this is a relational database. It doesn't have to be. It can be a graph database. It can be a document database, whatever you need. And the fun part is you can remove this. You can delete it any day of the week, and you can recreate it from your events. It may take 3 days, sure. It may take 3 days to recreate it, but it's possible. And sometimes you want to do it. And going back to that report for your boss, this is the source. And you would just create another consumer that would read through all the events and would create a secondary table. And this is the last bit. Pops up plus projection. I kind of touched on it on the previous screen. So we have a continuous process that consumes every event from a stream and creates a representation in SQL database. What it gives you is the ability to do this. Let's start from the bottom. This is just a model, fancy namespace, that's all. So we have an account model where we can find an entry. How do we update this entry? We issue a deposit command. And you can probably kind of see what happens. We have a command which gets transformed or produces an event. That event is projected to our SQL data table, and we can read it. This way, this is something that we are used to. And the syntax is very, very, very similar. We just call, not update. You can probably imagine that once you issue this command, this doesn't immediately pops up. So this data is out of sync for a second or for half a second. This is called eventual consistency. And once you learn why you can use it, you will understand that the fact that when you update, you don't have the outcome right away is not such a bad thing. But that's a longer story. Thank you very much. That's the end of part 2. I tried to show you a few concepts that took me a while to understand while going into event sourcing world. And the next part would be showing actually how it works, but maybe you have questions beforehand.
So, from what I understood, you worked with the MessageDB database, right? And have you maybe worked with Kafka in similar context? And if you did, are there any advantages or disadvantages of using MessageDB over Kafka, apart from Zookeeper?
I haven't worked on production level with Kafka, but I've heard this question a lot of times. And if you ask it to the mentioned Scott Belwer, one of the co-creators, you will get an awesome answer, because he's the guy when you ask 4 words and get 4 paragraphs in return, or 4 pages. But he often mentions, because he gets that a lot as well, that he often mentions that Kafka is awesome. It's an awesome tool, but it's an enterprise level tool. And if you want to fully use Kafka, you have to have enterprise solutions and problems. Because if you don't have enterprise level problems, then you will get them because you started using Kafka, and probably half of your staff doesn't really know what they are doing. In this one, this is much, let's say, simpler, even though it's not that simple. And this one is not really meant to be used at that enterprise level. It scales really well, really well. And if you need more than Eventide gives you, you have money to go everywhere, to change. They also, one of the previous implementation, I don't know if they still support it, they at some point decided not to stop, but they used to support the commercial event store. So you could use Eventide with Event Store, which has much more scaling capabilities than Postgres. They decided at some point to stop supporting that, as far as I know. And I've heard one quote: if you need the level of support of Event Store, the actual commercial Event Store, then you have money to do so. Then you can use Eventide, still use Eventide. You just have to adjust. So I cannot really compare it to Kafka. From what I understand, it's a different use case, really.
We have working second microphone, so if you have more questions, I can pass it on.
Okay, maybe let's have a 1-minute break, and I will set up and I will show you the magic. All right. I have some notes, so let's check what was in here, and it's not this. Practice. All right, so let me show you what do we get with MessageDB. That, as you may remember, it's an event store, so basically a message store, and this is installed into CLI. We have quite a lot of sub-tools. So the only thing that you have to do prior to start is run mdb createdb. It creates a separate database with proper permissions, with that message table, and you can start using it. I already have it, but just to be safe, let me run mdb recreatedb. That's it. Eventide publishes components from which you can learn. It doesn't contain much description, even though the documentation that they provide is really awesome. But the components themselves, Eventide as a company, they use those in workshops. So they are not well documented. However, they are very extremely well maintained. The thing that I've done when I first started is I've taken this component called account component, and when commit by commit, because it's so well organized, there are some exercises on the way described in the comments. So I advise you to do that if you'd like to get into these components. All right, so account component, it's a Ruby project. Oh, Eventide also provides a component generator. So when you want to write your own component, you just write like EVT component generate, something like that. As simple as generating a new Rails application, or even simpler. Let's see what it does. First of all, we won't be looking into database directly, because someone has created an awesome tool called MessageDB Viewer. For now, we have nothing, because we have no streams. All right, so let's create, not this window. Let's create our first deposit. Eventide components have this awesome feature, because how you test it, how you test something that you cannot click. You cannot open your browser and click buy or add to cart. Well, you can, but work behind that would be longer than the component itself. So they have two sections of tests. One is called automated, and those are similar to all the tests that you know. But the other part is interactive. So interactive tests actually do something in the real world, in a real database. Holding microphone in one hand, let's copy, let's paste. This has put an entry in account command 123 stream. Let's see how it looks. Of course, no refresh. This microphone thing is... okay, let's try it. So our interactive test did just one thing. It issued a command, as I described previously. So we have a command in account command. Again, account as a bank account, so we can deposit and withdraw. The command is there, but nothing has happened. Why? Because our consumer is not running. So let's run it. Let's run a consumer. It has some information here, for example, what types of messages it handles, it consumes. Let's see what happened in here. It normally auto-refreshes. I just have no internet connection, and then it breaks. Nevertheless, we had account command. It got consumed and produced deposited event. Simple enough. Let's do something more fun. If you have any questions at any point, please let me know. We need another. Let's leave it like this. Let's issue a withdraw command. So we've deposited something, now we want to withdraw. Again, our consumer we have a new command and a new event. When we deposited, we had data stored, data called amount, value 11, deposited amount 11, withdraw amount 11, withdraw the same. Let's try to withdraw it again. As we can count, we added 11 and we subtracted 11. Let's withdraw again. Our consumer, which is somewhere in the middle of this blue line, conceptually, has seen this command, has projected in memory all the events that has happened so far, and concluded you don't have money for that. So it has created withdrawal rejected rather than withdrawn. Let me show you how it looks. It's a very simple block of code. And the beauty behind all this is that all the business logic is a very simple piece of code. This is the place which handles the withdraw command. Sorry. What happens? From the withdraw command, we read account ID. We fetch all the events related to that account that has happened over the time. What happens in here? We project all the events into an entity called account. This is a class. It's a Ruby class which contains all the data projected from the events. I can show you later on how it looks like, but it might be a bit too much for now. This is just something for idempotent, which I don't want to go much into right now. However, the events, the commands, you have to know if they have already been processed or not, and that's a very hard topic in general. But to put it simply, we take the command, we take all the events, we decide whether we have sufficient funds, and we either put withdrawal rejected or withdrawn. And this is pretty much all this component does, at least on this level. Let me show you something much more fun, and I will just show you and describe in a few words, because that one is might be too complicated. But if you'd like to talk a bit more, maybe afterwards I can describe it more. Let me open the other example. It will also be based on this account, but what we'll be doing, we'll have two accounts, and we will transfer funds between them. So we will take funds from one account and put it into another one. 1 second. All right, so we are now in the second component called fund transfer. And the interactive test in here does two things. First of all, it deposits just as we've deposited a second ago to an account, because this fund transfer component relies on that previous account component. So we deposit first, because if we want to transfer money, we have to have some money, right? And then we issue a transfer command to funds component. Let's run it and let's see what happens. All right, so we've issued two commands. Let's see how they look. And again, nothing has happened. So we've set out to our system, do something, and it didn't do it. Why? because it was offline. Our consumer is not working. And this is a dreaded situation in every or most of microservice implementations. You do something in one service, it calls another service, but it was offline, so your REST request fails, and then you retry or say to yourself, eventually it will catch up. I think it sounds familiar. This, as I will show in a second, the introduction of MessageDB and event sourcing is an introduction of how the microservices should behave. It's not that we can make every piece of communication in microservice world asynchronous, but this is the ideal way. And just FYI, the REST request way is not the only one. So we've said to our services, do something. Let's start them now. I have to start not only the funds transfer component, but also the account component, because that account component is responsible for handling, for example, the deposit command that was issued. Let's see what happened. This one will be a bit complex. So first of all, I will add them all just to show you the initial complexity. It's much worse when you try to read it from database directly, I assure you. And we can analyze it a bit by bit. However, I don't think that's that bad. All right. So, first of all, let me just go over it in like 3 minutes, and if someone is more interested, I'll explain later. So one thing that has happened, we issued a deposit command to that initial account to have some money to transfer. So we deposited, it has deposited, and that's the end of the story. One story. Then we had our fund transfer. Oh, shit. And we issued, I cannot do it with one hand. Our fund transfer received transfer command, which ended up as an initiated event. The names don't always match. It's not always add line item added. It's initiated event. Now, what happened in here? The fund transfer was set to withdraw from this account, deposit into this account, amount of 11. So when it was initiated, then it has that might be just too much. Fund transfer has issued a command to account withdraw. The command has been consumed by a consumer into withdrawn event. And now we go back to PubSub. Account was set withdraw, produced withdrawn, and fund transfer is subscribed to this withdrawn event. Once it sees it, it can safely say, okay, money has been withdrawn. When it has been withdrawn, it issues another event, another command to the second account, saying, hey, this other account, I've withdrawn money, now deposit it. Once it's deposited, me as fund transfer, I'm subscribed to this event, so I can safely say, okay, it has been deposited. And as a closing event, in fund transfer, I create transferred. This example has been simplified from what's actually in the fund transfer component. It has a bit of idempotence checks on the way and mechanics. I just wanted to show PubSub in action. And actually, if you fully understand this example, with the techniques that I've removed it from here, you're practically ready to create your own component. Because this is complicated. And the reasons why things has been done in here the way they were is complicated and complex. And the more it's like, the more you read it, the more you understand it. And when you come to it after a month, you realize, hey, there is more to it. The examples are very simple, yet they have been introduced because of very specific reasons that you have to understand to enter this world. However, the community is very helpful. There is quite a lot of material. The documentation is awesome. There is a Slack, which you can join, where you can ask questions and people have done that. So basically, this is how it works. Just as a bonus, let me just wrap it up. One bonus. I've already mentioned it. Microservices. There is an awesome, not linked here, but there is an awesome interview with Scott Belwer by Polish team, Arkansas. And it's in their pages. And it has changed a lot of things for me and has really changed the way I'm thinking about a lot of things. Because probably, guys, in your software houses, once microservices hit, you all start learning Go or Kubernetes or some extensive Docker things. I know I have. And you tried to put your monoliths into microservices, and that's just wrong. This mechanism gives you the ability to do it right. And also, if you want to know much, I mean like much more about microservices, go and watch this. The link will be available in a second as well. It's 40 minutes, but it may change the way you think about it, like completely. So if you take anything from this presentation, as long as it is, please just do two things. Watch this. Greg Young, he is like an evangelist of event sourcing. And watch this. You'll get much more than you get from this presentation. Both are awesome talks, really, really worth seeing. I think I watched both like 2 times. And the link to this presentation is in here if you would like to revisit. Okay, thank you very much. That's all, unless you have questions.
So how do you calculate the global position? Because you use UUIDs to have an ability to generate the events in different places, but then finally you have some kind of global ID and global position. And what is like the defined source of truth for the order of the events?
You can always, every time you put something in, it gets the sequential position. There is one source of truth, there is one database, so one table. Every time you put in something, it gets the sequential ID, not ID, sorry, global position. Yeah, it's pretty much just in Postgres. Unless I'm not getting, unless you're thinking that there are multiple sources and you have to decide. Let's start again.
I was thinking about the case when you have like two producers and one will lag with for something, generate an event and won't be able to like, you will have like race condition from two sources.
You don't really rely on global position for anything unless it's a difference of positions. So, for example, if you have, you might remember from the beginning of this presentation that event sourcing is storing messages in append-only log. So, normally when you have Postgres and you have incremental ID, you can decide what happened after what based on ID. You don't have this situation in here because IDs are UUIDs. However, global position stores you the order of the world as seen from the position of MessageDB. If something has lagged, then it has happened later. If one of your consumers got offline for whatever reason, then whatever it would have produced or would produce just happens later. And I feel like I'm not really getting into the gist of what you're asking about, but the global position is not a race condition. There is no race condition in here because if you, for example, when you have an event that costs something else, the difference between the global position of this event and everything that happened in the future, that would always be the same in the same order. And for example, okay, so let's put it like this: if you have an event that costs two different branches of events, and then you never rely on the order of those. Actually, one in comparison to the other. I probably have to rethink the question itself because I feel I'm not really getting into the answer, but let's try maybe in a second, unless you'd like to rephrase it somehow.
Dobra, dzięki, bo będziemy musieli się powoli zabierać z sali, także świetna prezentacja, dzięki.